Thank you, Willi. It's always amazing where you get around to all the different shows. So I'd like to invite Ryan and Mike to come back up and remind you again that if you have a question, please raise your hand and one of the cafe members will bring you the microphone. We need to have it so that we can record it, and I'm going to give the speakers the mic as well.
Again, thank you for a wonderful presentation. I'm Surya Pedinti. I'm a private inventor of closed-loop electric propulsion. Will, you spoke about the future of electric aircrafts as well as the strain on the grids, as well as Ryan, you spoke about the Uber Elevate, as well as Mike, you spoke about the aircraft evolution as well as how it is progressing. So given that, my invention, it solves two things at a time. One is the range anxiety. It gives the unlimited range as per the battery packs lives are there. And I can reveal all the circuits and everything. It is made possible. And also it has zero strain on the grid, meaning it doesn't draw any power from the grid. Instead, when it is ideal, it will supplement the grid. It will give the excess power back to the grid. So each and every vehicle will act as a mini powerhouse. So where it comes as a critical player is for e-ports, you don't have to depend on the external grids, and that can be conveniently located, as well as the range anxiety is absolutely zero. I have validated my invention with an electrical engineering PhD professor, and they were astonished by it, and also with several other people. Given that, what is the scope of these kind of inventions getting adopted by the industry?
I'll speak first. Generally speaking, one of the things that we're excited about is that electric flight is really advancing the state of the art. As you said, there's always new people bringing forward new inventions. At the same time, we have to talk about the certification challenges that we face today, and that will require us to leverage the knowledge and skills and experience that we've built over the past 10, 15, 20 years in electric flight. So to that end, when it comes to designing vehicles for an urban air mobility mission, at least from my standpoint, we suggest that we use the technology that we have available today and try not to expect that a remarkably new technology is going to be what enables us. We have to make sure that we're speaking based on the technology we fully understand right now. We're excited about perhaps your invention. We would love to see more about it, I think. Yeah. But Mike?
Yeah, so I just wanted to comment, I put my 5 key challenges there about what for something on urban air mobility approach like what Uber has. And so I got kind of beat up saying, no, we can do this. There's no new inventions required. It's just a matter of, it's engineering at this point. It's not technology development. So I think there is a baseline capability that exists today. In fact, you see that there's now the ultralight aircraft by Kitty Hawk and others that are flying, very limited. And natural technology improvements for batteries and things like that will just improve over the next decades and having better capabilities. But absolutely revolutionary technologies like what you're talking about will get us there faster and better and have much more. There'll be much more capability, and again, the economic viability or profitability of these aircraft concepts.
Yes, I think there are 2 things. One thing is I really would like to see more about what you're doing there, what you're talking, and if it is enabling and accelerating the process, very good. But like the other 2 next to me already said, it's at the moment, with the technology we have, we already can make electric aviation possible, and there will come your technology, there will come other technologies which will enable, which make it better, but at the moment, I think we can rely on the technology we have, and we have to, and I'm happy to look at your informations and to publish it, to get it out to the people, to get, and that's why we need the network, that's why we need this kind of events, to get people together who need this enabling technologies, which will help. But it is not that only with this kind of technology, because this is something which I hear since I started electric aviation. Yeah, it will never work, the batteries are not there. It will take another 20 years before the batteries are there. I don't think so. We can do it right now, and if there come, and I'm sure there will come new technologies, it will get faster. That's good.
So here what I would like to suggest is, this is simple electric circuit modifications, nothing new or nothing rocket science in this. So it's easily adaptable. I mean, I'm not saying mine is only easily adaptable. There could be millions of technologies which could be easily adaptable. Those kind of technologies should be encouraged and innovated instead of putting a lot of regulations in place before adoption. So that's where I'm requesting people like you to look in a different way and see that how faster it could be absorbed. I mean, because we are in a fast age, and we should look into some of these things in a different spectrum. That's my humble request.
Thank you.
Okay.
Got a couple of questions in the back. Thank you for your question.
This is Peter Shannon with Radius Capital. Question for Ryan. When you think about Uber Air in, say, the 2026 timeframe, when the capacity of the system is still probably relatively thin, how do you really anticipate the customer use case working? How's the customer going to interact with the system? It could be, booking a trip could be like getting a table at the most popular restaurant in town, given that there might be a lot of demand for this type of travel, in particular on the routes that you pick. So is this like an on-demand, spur-of-the-moment type of travel booking and then go and get on the flight, or is this something that people book days ahead in advance? How do you see that working, and how do you see it evolving over time?
Sure, and I think that the answer that I'm going to give is really kind of time independent, because we're actually doing this starting this week with Uber Copter, and this is the same sort of vision that we see moving forward with urban air mobility. We want this to be a practical, instantaneous, time-saving service that you, in the same way if you were to order an Uber X or an Uber Black or Uber Pool, it is just another option when you're in a city that has that available service, and it's a trip option that makes sense. It's offered to you, it makes economic sense. We don't want this to be an exclusive service. Right now Uber Copter is utilizing Bell 430. That's an expensive vehicle to maintain. It's an expensive vehicle to operate. The thing that we're trying to unlock with eVTOL is much lower direct operating costs, such that this is a service that is accessible to anyone, on demand, instantaneously, right through your app. I highly recommend taking a look at some of the summit content when it comes to Uber Copter, and I'm sure there will be more information about this soon. I've actually used the service, and it is so seamless. It is as if it was part of the Uber app from day one. I mean, it really is astounding, the work that's been done on the back end. I don't know if anyone has...
Hi, this is Glenn. I'm from Boeing Horizon X. Several of you mentioned that initially you're going to plan to rely on pilots to man the eVTOL aircraft. As I'm sure that you already know, there's a huge pilot shortage. It's only expected to accelerate over the next 5, 10, 20 years. And then eventually they'll be replaced with automation. How do you anticipate building that initial pipeline? And then where do you think those pilots will move on to later on in their career once they're forced out of these small eVTOL aircraft?
So I think one thing is, which is clear, that I think the pilots which we have there, they don't have to have an ATPL. Perhaps they will have at the beginning, but at a later stage it will be, I think, a special pilot certification which you need there. Second, it's very clear that and I think the second point is the automation, and perhaps even autonomous flying will come much faster
than we think today. That's my clear, because otherwise all these models will not work. So I think although as the automation is implemented in the vehicles, I think from probably day one, the pilot capabilities which are used are much less, because you know, it's not like a helicopter pilot, because you cannot fly this aircraft fully manually anyway. You need computer assistance to fly 18-rotor multicopter. You don't have enough fingers to control each motor. So there will be a lot of computer assistance. So the pilots we will need for this, and this is one of the things we have to develop with the EASA, FAA, and others, this pilot skills, pilot licenses, which are need for this, which will be used there. And though we shouldn't think too much in nowadays lines, because it will be very different.
I have two things to add to that. Willi showcased at the end of his presentation sort of the astounding pace that the electric trainer aircraft market is moving at right now. The E-Flyer 2, the Pipistrel Alpha Electro. So first of all, the barrier to entry to becoming a pilot is going to fall dramatically. I think the ability to build time and build hours is going to grow. Second, we believe that for these simplified vehicle operations, and especially for single pilot aircraft, we need to start moving to simulator hours being accepted towards the commercial operator certificate. It's going to be very difficult to build 500 hours of powered lift license technology or hours without simulator technology being accepted as relevant training. And then the third thing that I'll say is to consider the life of a present commercial pilot, one who may be dispatched anywhere in the country at a moment's notice and spend many days away from home. You know, the service that we're talking about operating is within one city. It's regular hours. It's going to be the type of lifestyle that our commercial pilots are not accustomed to today. And I think that they'll see a lot of value in that, and it will be a career path that will be exciting to them, valuable to them, and we're really looking forward to creating new opportunities in aviation. As far as automation goes, I don't want to put a specific date on it. As a former aircraft mechanic, I do have some opinions on this. The most dangerous hours to fly are typically the first 10 hours after significant maintenance. I think that I can tell you that that's a fact. And that's in rotorcraft, that's in fixed wing. Mechanics make mistakes. We really do, and we try and QC all of our work, but sometimes things happen. I think that the first automated flights will probably be the ones that come after maintenance activities, even in our piloted vehicles. I think that the piloted vehicles, like Willi was saying, are going to have the ability to fly autonomously inherently, but we're going to probably do like a crawl, walk, run, and I think that the crawl is after maintenance. We do our test flying, perhaps automated. So someone just mentioned 737 MAX. I totally think that should be something that is acknowledged. Automation in the cockpit is changing the way that we fly airplanes. But I think that one of the lessons from the MCAS incident is that we need to be developing fail-functional automation systems.
Even if you create a software system, you're human, you make mistakes. If you implement a system in an aircraft, you make mistakes. If you say they need only this little training and they should have had much more, you make mistakes. But this doesn't speak against automation be safer in the long term, because like we learned, like it's more than 75% of the accidents we have right now in GA which are implemented by pilots' mistakes. So I think the Boeing 737 MAX thing is not which is speaking against autonomous flight, or it is for redundancy, for safety, and for being very accurate, better than fast in developing the systems.
Another question.
My question is on the timeline. This is Severin with Horizon X. Mike in his presentation said that where we find ourselves right now on the hype curve is really between innovation and the period of inflated expectation. But Ryan is telling us that in 2026 we're going to fly. Can you explain how it's going to be possible if we, in reality, find ourselves going up in the hype curve? Are we really going to reach that level of productivity by 2026?
So 2020, I think, was a number that was questioned a little bit earlier. Let me first say that 2020 are not going to be certified passenger revenue flights, I don't think. I think we're going to be talking about experimental type certificates, experimental operations, with the goal of 2023 to be the certified revenue carrying flights. I can say that this is a very exciting time in aviation, and that I believe strongly in the timeline that we've set for ourselves and that we're challenging our vehicle partners to. I think that the timeline always is going to put safety first. So we're not going to rush things to market without doing our due diligence on safety. But I think that you'll be surprised at how things develop. And that's all I can probably say on that.
Yeah, and I just to say, I mean, Uber has very, very aggressive goals. I think there's a very good chance they can meet those. And one of the reasons is because they have really, I used to say when they first started talking about Uber Elevated, that it seemed laughable at first, but when you really, as I said, peeled back the onion and looked at all the different layers, I mean, they've done their homework. They've got lots of experts. They're addressing all of these different questions. And that was really kind of my statement that I was trying to make is you got to do your homework. This is right now there's so many challenges and things that can go wrong that will make this more difficult to meet that timeline. But I think that proper planning and expertise and investment is how that Uber and others will solve that.
Ken.
Okay, I've got two questions. I guess one, I guess for Mike, is what has surprised you since this eVTOL industry has unfolded that you weren't expecting? You've been steeped in the helicopter industry, and what have you seen that's sort of even caught you off guard?
Well, a couple things. One is, like I said, kind of every kid with a computer thinks he can, design an eVTOL, and it's the greatest thing since sliced bread. But one of the things that was really a watershed moment, in January of 2018 in San Francisco, we had our fifth eVTOL symposium, and we had it at a helicopter meeting. And it was, the world's helicopter and rotorcraft experts from the Army and NASA and industry, and we had that in conjunction with the eVTOL symposium, which were all the Intel and Amazon and Joby and all the different companies that were developing eVTOL aircraft, and it clicked. It was the crazy inventors and the established rotorcraft community, and they saw each other eye to eye and said, we can make this work. This is, it wasn't the rotorcraft. It was, at no time did the helicopter industry ever say, we're going to fight you. There was no us and them. It was a we. We are the vertical flight industry, and it was just really a watershed moment, I think.
And the other question, probably for Willi, is in Canada we have 37,000 aircraft, and there are 5 electric aircraft. I hear the promise of electric flight training, and in some ways it seems to make sense. And why is it not more pervasive now? What are we going to reach a point where there's something going to be an S-curve on electric flight training? I want to sort of understand what's going on there.
I'm quite sure it will be there. Right now, it is mainly, there are 2 major factors which stopped it. One is the technology had to develop, which is clear, but the other thing is the certification has to be somehow adapted, because the first aircraft we've seen has been developed in the ultralight class. Why? Because it was just less difficult to get through the certification hurdles, but you have the limit that because of the limited weight, you only can take very little battery on board, so it doesn't make really sense to do flight training, especially when you want to keep your VFR reserve. On the other hand, you know yourself, in the United States, this dereglemented class was, I think by an error, designed that you could not use electric motors, and it is still not solved this problem. So you can't use electric motors on LSAs, so the most easy class is exempted, so we just left with the class. And when you talk about electric training, the thing is, it has to be certified. You cannot take experimentals because you can't train on experimentals. So this is why I think this year we will have the first CSLSA like the Pipistrel, certified electric aircraft, and there are other approaches like the flight design with a Siemens motor, which I had in one of my slides, because they designed an aircraft which is basically fits in the new UL category with 600 kilograms, but the same airframe will be also used for a four-seater later. So from the stability standpoint, you could put another 300 kilograms of battery in there, and then you really achieve a reasonable range of 2.5 to 3 hours. And this is doable in Part 23, new rewrite certification. It is done now. It just takes its time, the certification. That's why I mentioned certification is so important. It's just that the aircraft you have now, they are just one-offs, except the Pipistrel. And Pipistrel is only operating in some few countries where they have the certification. Unluckily, these are not the huge countries where you have a lot of flight training. But I think at one point, for example, China, where there will be a lot of flight training needed, at one time, when there are really reliable aircraft there, then it definitely will go much faster than you think, and then the numbers will go up. And you will see, like at some point when you had, let's say, 700 Cirrus aircraft sold in a year, I think it can reach this kind of figures, and it will. As we have a pilot shortage, I just heard now that from the LSA point of view, the United States, I think it's either Air Force or Army, they will use for the first time LSAs for the evaluation training of pilots, and the costs will be, I think, 1/10 of the costs they pay right now, because otherwise they use much more expensive aircraft. So having then an electric aircraft implemented there, where the cost will be even lower, I think it's a must if you want to do flight training that you will change it to electric.
And, excuse me, yeah. Here, and then we'll go.
I
to
just
Reg.
repeat, he just said India has ordered 100 Pipistrels for flight training. I know this, yeah.
Okay.
Good afternoon. I'm Gary from Annapolis. Got a question at a very high level. I'm very impressed with Ryan with your notion of the technology to do this urban mobility. As an outsider listening to this meeting today, I'm interested in your ConOps, your concept of operation. How high will you fly? How will you be integrated into in the U.S., the national airspace system? But it goes beyond that. We talked about the certification basis. You mentioned Part 23, and yet you may have issues with special conditions. I don't have a clue on how you plan to integrate the training, the flight training, the whole integration. So is this a issue here for Mike? You mentioned the issue of global interoperability. Is this an annex that you envision under the ICAO process? Do you envision an RTCA special committee addressing for Ryan's eVTOL concept the following? Could you add some substance to help me, or offline to try to educate me?
Sure, there were a lot of questions and and that's sort of the nature of this challenge of the urban air mobility is that there are a lot of problems to solve. Let me start with the first piece, and then maybe we can address some of the other things with my partners here on the stage. The use space, so that'd be urban air mobility, and unmanned aerial vehicles typically is within 2,000 feet above ground level. We're not trying to reserve special flight corridors for people, for our initiatives that no one else can fly into. We believe strongly in equitable airspace. To that end, these aircraft will be able to operate both within the urban air traffic management systems and also the traditional air traffic management systems. There will definitely be touch points between those two. At scale, it will definitely be a challenge. You won't be able to operate 100 vehicles in urban airspace if you have to communicate by voice, by radio to air traffic controllers. And so we have to embrace new technologies and the ability to dynamically adjust routes and have that technology in the cockpit and also at the air traffic control layer as well.
Okay, but follow me through. That was a verbal vision. What I see a need, if you want to hit this 2026 IOC date, is to sit down with the air traffic provider, with the flight standards regulator, and with the aircraft cert people, and maybe in a consensus group like RTCA or SAE or other form, to try to start your substance.
To address your
Has that been
concerns,
done, or is that
we have done that. So we have some of the best minds in airspace working this problem and working directly with FAA. I was actually just in Australia 2 weeks ago to introduce these concepts to their Air Services Australia and CASA regulators. So I can tell you that these things are being addressed, they're being communicated, and we have established work streams to make sure that these problems are solved.
Just to add, perhaps also the point of view which we have in Europe, for example, just like in Germany, there are right now 3 test areas, and this is like how it's going to work. You're going to have a concept, then you're going to have test areas where you're going to try out, and this is happening right now, that they're ramping up these test areas where you will be able then to fly autonomous vehicles, semi-autonomous vehicles, and see how they can be operated. But that's the point where I made the comment before, why I think with the system we have installed now, even with ADS-B in and out and everything, it will not work. We need, also in this field, new technologies for the communication, vehicle to vehicle, vehicle to ground, vehicle to the control operations. But these talks are happening right now, and so I'm confident by the time where the vehicles will be ready to operate, there will be the test areas ready to operate. And so that's the only way how it can work. And you also have to see these vehicles at the beginning and also later. They will operate on routes. It will not be the air taxi will take you from your garden into your neighbor's garden and you fly there or you program it and the autonomous. It will be on routes, it will be programmable, and so also the extraordinary events, like if you have a failure, where you have to land, the emergency, everything is previewed in the systems. So it will be quite rigid systems, especially in the beginning, on which these vehicles will be operated.
I just wanted to mention that, yes, there are lots of standards groups involved. So Gamma has been very active. You see Gamma's logo on the cover of Willi's magazine. He's part of there's an EPIC committee that they started in 2015 or 16. ASTM has been very involved in standards. SAE, you have some discussion of that. RTCA also. So there are lots of, we don't do standards, but there's lots of associations that are doing standards, and there are several projects with both the FAA and EASA working with them for aircraft certification. So lots of stuff is going on.
I'll just add to that NASA, of course, has been working on UAM traffic management for a number of years now. And tomorrow morning, both of our sessions, we have sessions on standards and certification and another one on safety and operations and infrastructure. So we'll actually get some more input on this tomorrow morning as well. Rich, you have a question.
Yeah, Rich Lehman, RYL Analytics. I really applaud Uber's effort. I'm just flabbergasted. But I have a concern as I understand how complicated the infrastructure and the air traffic control and the certification. And I have a challenge, and that is for trade studies to be done that don't assume the current infrastructure. And I'm wondering where the ESTOL might fit in. Wondering if we're trying to go a step too far and we're missing a transition from a short takeoff and landing, more conventional, fits in the space better, versus biting the whole cookie at one time.
You want to go first?
I'll take a stab at that. So Uber's core mission is transportation within urban communities, and 90+% of the trips that people take are within very short distance. That's where we see, particularly in congested urban environments, being able to make an impact on how people move. And I'm sure that there may be opportunities for the e-stall activities. It's just not the area that we're focusing on.
I may mention, yes, there are several people who think like you. I know, for example, when at Aero this time, I had Frank Anton, the head at that time still of e-aircraft, and he also mentioned that he thinks maybe e-stall will come before eVTOL, which is obvious because like the certification hurdles will be less. You will be operating from airfields, so there will be less things to change in the system. But I don't think it's contradictory to that eVTOL will happen as well. But I agree with you, probably e-stall on the short distance will happen earlier, and there are several companies around the world working on this.
I'm Kurt Longo. I'm a private consultant. Just a few more specifics, if we can kind of extend the previous question. What do you see as the impact of the special conditions that were just released by EASA, pro and con? I've been through them, and I don't see a whole lot of difference there, against Part 27 for helicopter certification or rotorcraft. They don't look a lot different to me. One of the primary issues I've had is trying to understand where the batteries fit into the ATA chapters. If you look at the ATA chapters, Chapter 24 for electrical and I think 28 for fuel. If you look at 28 for fuel, and it's a battery storage medium, then that evokes 25981, which is flammability for center fuselage storage and wing. So those are the kind of specifics I think we need to be talking about for the certification of the vehicle. And I'm also going to say that 23 is great for personal use and also up to maybe 19 passengers, but when you really start looking at the model that you're looking at, it really should be looked at Part 25 because that's more of a commercial standard. You're going to be carrying people. They're paying passengers. You can't ignore 25. We're not going to get that big right away, but I think that's something that needs to be looked at.
I'll answer the second part first. I believe that currently we do have passenger service, revenue passenger service on Part 23 vehicles through Part 135 and similar activities. We believe that the risk exposure on each vehicle and in general maps correctly to a Part 23 vehicle. There are parts of Part 25 that I think would be appropriate to consider when it comes to fly-by-wire systems, but we can get to that. And I think that, again, this is going to be for each aircraft manufacturer and not necessarily Uber to be deciding. This is not up to us. This is for the manufacturers and the civil aviation regulators to negotiate and decide. Going to the first part on EASA SC, I applaud EASA for taking strong leadership to enable an industry that's so new, and I think that if I was to speak anything in a criticism way, I would have hoped that they would have moved together with other civil aviation regulators such that there was international alignment on how we were going to deal with these issues. And you know, to that end, I would say that the performance-based standards, the Amendment 64 type changes that we saw to Part 23 were something that were adapted internationally, and you can look to many different civil aviation regulators, and they have pretty good harmony on that. I think that we can do better, perhaps, on SC eVTOL.
Yeah, I mean, I also applaud EASA for, forward thinking. I think they kind of jumped the gun. You said it's similar to Part 27, but I mean it's 10 to the minus ninth for the enhanced, for the passenger carrying service. So, however, orders of magnitude above helicopter requirements, for instance. Having a special condition means they have to have special conditions for operations, manufacturing, and everything. So they may have actually set the industry back by 5 or 10 years to have all those operating procedures and everything developed. So right now, if you fly in to an airport or whatever, say, I'm a helicopter, I'm a rotorcraft, or I'm a fixed-wing aircraft, and now it's, I'm a VTOL. So what is that? How do you handle that? Rather than saying I'm like an airplane, but except for these, 5 or 6 exceptions, or I'm like a rotorcraft except for these exceptions. Now there's a whole new. I mean, it's a lot of unplowed ground. Now, if they can develop all those special conditions or operating conditions for this SC VTOL in a very timely manner, then maybe they can, maybe it will be a net positive for the industry.
I just want to say, so right now I think EASA, that's because we talked about this at Aero with the certification people of EASA, and they said this what we put out there is not graved in stone. It's actually, that's why it's not a CS, it's not a rule, it's a proposal what we do right now. Yeah, but...
It's an SC, not a CS.
Yeah. So I think you have to start at some point, and especially the discussion which you had, or what you was mentioning before, like, should we take Part 23, or is Part 25 with some parts from 23, or the other way around, more appropriate? This makes sense, and perhaps thinking, okay, why not try to start at something new. At the same time, I agree totally with Mike, you have to have the way how to solve the operations problem, but also there, the operations, we have to admit, will be very different from any aviation or helicopter operation we've done there. So to say, okay, we can swap it in there and then make it more easy to get it airborne faster is something we will have to have a period of time where it's experimental try-out operations anyway before we know where it's going. So I think both approaches are feasible, and I'm quite sure after how good it worked in Part 23 rewrite, I'm quite sure, and both sides say that, FAA says it, and EASA says it, and the Chinese say it. So I'm quite sure they will move along also, and they will find on some point together again. I hope so, but I also think so, where we will have a standard which is operational as fast as possible. Because they have a lot of political pressure. Because if you see all the big names, which have a lot of political connections around the world, which are in this business now, you can imagine, and I heard from EASA people, that there is pressure to get things done quickly, and there will be budgets for getting things developed quickly, so we do not have to think, because like, if I look at how long it took to get the new radio frequency implemented in all GA aircraft in Europe, if it will take so long, we will not fly in my lifetime with an eVTOL. But I'm quite sure it will go much faster because it's a disruptive change.
Based on what? Certainly not the history we've had over the last 100 years. Things just don't move that quick. I'd like to think they would, but if we look at over the last 50 to 75 years of the regulatory body for aviation in the world, things move at a snail's pace. So I guess I'd like to hear a little bit more on why you think it's going to have such a pronounced speed of delivery. Also, a point of clarification is Part 23 is for unscheduled air carriers, not scheduled. So I don't know what the Uber model is, but
it is unscheduled service. I'd also just take it a step further and say, we're not suggesting 23 is applicable because it's easier. That is not, there's no one here who wants easy certification paths. We want safe, reliable vehicles. We have no incentive to have a vehicle operational that is not commercial operation level safety. I think, though, we need to be thinking about what is the appropriate path forward for a type certificate of a vehicle of this class. What are the ramifications to the rest of aviation if we start saying, well, you guys are different? I think one of the interesting things about EASSC is that it couples operational with vehicle certification. I don't know that that's appropriate, but we can have debates about that for hours. I think the one thing that you have to also constantly be talking about when it comes to aviation safety is operational safety is 70% of fatal accidents. We, as an operator, potentially one day, stand to make an enormous step change in operational safety. We need to. Because if you go to 10 to the negative 9 on vehicle engineering, you're still going to eventually be dealing with smaller and smaller and smaller pieces of the actual level of safety. And the contributions to fatal accidents will be operator induced almost all the time.
No.
I'm actually going to say we could keep talking all afternoon. I really love this discussion, and I know there are people who would really like to take a break. So I'm going to call the discussion as a group discussion now.